Welcome to the last lecture on casting. We have discussed about the casting processes, the various terminology in casting and certain numerical problems in the previous lectures. In this lecture, I will walk you through the virtual laboratory, that is the laboratory session. We will walk you through the V-Lab. V-Lab is a set of labs which is developed within India by different institutions, so that the students who are not able to visit the lab in person should be able to take that experience while working on computer itself. So, you are in the course Basics of Mechanical Engineering 2. I am Dr. Amandeep Singh Oberoi. To see the V-Labs, I will start very basic. How do you search V-Lab in the Google? So, I am here at the Google Chrome. I will just type here V-Lab, or I will type here V-Lab casting. The first link that you see is the manufacturing processes, foundry and casting. This link you will open. I will click the link. You have seen the link is opened. I am just zooming it out so that it is more clear on your screen. There are certain experiments on foundry and casting in this virtual simulation lab, like to study and observe various stages of casting through demonstration of sand casting processes, to design and manufacture a wooden pattern for a given casting. To design a cut means to cut the wooden pattern, the size of the wooden pattern has to have all the alloyances which are there in the casting that is required. The final casting that is required, the wooden pattern, because shrinkage is there, lot of alloyances are there which are to be put together. Then the third experiment is study core and core making, the core of the casting. Core is always harder than the other casting body. So, this also is one of the experiments to perform strength tests on sand. You know, the properties of the sand are maybe refractoriness, that is the high temperature, how does it behave, cohesiveness, how does sand particles stick together, then dry strength we have, then we have green strength, then permeability, that is porosity, all those properties are there. This is one experiment of permeability as well, as you can see in experiment number 7, to determine the permeability number of green sand, core sand and raw sand. There are a number of experiments here. I will just walk you through 2 or 3 of them. The first experiment I will pick is to study and observe various stages of casting through demonstration of sand casting process. This I have clicked here on the experiment name itself. So, this experiment title was the link itself. So, you will see this screen that is open. Aim to study and observe various stages of casting through demonstration of sand casting processes. First part is theory, you will see here. The complete theory of sand casting process is given here, different steps such as pattern making, core making, mold making, melting, cooling, solidification, cleaning of casting. Each step is also represented here through a block diagram. The pattern making in itself is a process that has pattern making, core making and gating itself. Then this goes to the mold, and sand is also added to the mold, and melting of the metal is separately done in furnaces. So, pouring of the metal into the mold is done here. Then after the pouring of the metal comes the solidification, cooling, then shake out and removal of risers and gates which are put there when you design the mold. Then heat treatment, cleaning and finishing, inspection for defects and dimensions, so that finally it is used for the actual case wherever it is required. First step is pattern making. The details of the pattern making we have discussed in the previous lectures. I will not go through the whole theory here. Pattern making is a physical replica of the exterior of the casting with dimensional allocation of for shrinkage and finishing used to make the mold. Then core making, pattern is the overall body. If the casting that is you are going to make is having something hollow inside, for example, if you wish to make a hub or maybe a pipe which is hollow inside, the core has to be there. So, core making is also there, mold making is there, melting and pouring, cooling and solidification. This step incorporates the time span taken by the casting to cool down. Then cleaning of casting and inspection. Then this is casting terminology, this you have seen already. You can see we have riser system here. This is cope and drag, upper part is the cope, lower part is drag. The cope and drag system only we are going to learn in this experiment. So, we have riser system here, the gating system what we call, the riser, the sprue, the gate design, all those parts are here. You can see all these terms are further detailed in this flask, cope, drag, core print, parting line, draft, pouring cup, sprue, and in the sprue itself it has been given poor and good kind of the sprue design. It has to have a taper here, you can see a taper here. Then sprue base, riser, runner, gating system, the kind of top gate, bottom gate, parting line, all these things are given here. We will just go through the next step given here, that is pre-test. Aim, theory, pre-test. Pre-test means to test your knowledge about the casting before actually embarking upon doing the simulation. The simulation means you are going to do the casting in a virtual environment. Before going there, what knowledge you should have? You might have read about the casting, about the mold, about the cope and drag method. For that, few questions are there. For example, there is a question, which sand is generally used repetitively for mold making? The answer is silica sand. I will mark this answer. The purpose of gate is to feed the casting at a rate consistent with the rate of solidification. Yes, this seems to be the right answer. Act as a reservoir for molten? No. Help feed the casting until all solidification takes place? No. Feed molten metal from pouring basing to gate? No. The answer is feed the casting at a rate consistent. Next question is, the purpose of sprue is to feed the casting at a rate consistent with the rate of solidification? No. Act as a reservoir, help feeding casting until all solidification takes place. Feed molten metal from pouring basing to gate? Answer is feed the molten metal. This is the purpose of the sprue. Then the taper provided to the pattern for its removal is known as, what is taper known as? Yes, it is draft allowance. Draft allowance is the angle or the taper that is provided, that we have studied. So this is draft allowance. The function of cores in casting is to form extended parts? No, never. Form internal cavities? Yes, the core makes the or provides the internal cavity. Then use of for directional solidification, act as a reservoir? No. Let me submit the quiz. Yes, I have gotten 5 out of 5. Make sure you get 5 out of 5. For each of the answer, you will also find the explanation. If you click the explanation link here, it will find or it will give you the complete explanation that why this is the answer. Even if you mark the wrong answer, it will still give you explanation that what is the right answer and which answer you should have been marked. So you will get scores accordingly. 5 out of 5 I have gotten here. Next part is the procedure. Procedure for the sand casting process is given here: place, transfer, ram, sprinkle, fix, place, fill, remove, then removal of riser and sprue, then removal of pattern by removing guide panes, relocate them after remove of the mold, then pour, after cooling, click. This is the complete procedure. We will go through the simulation and try to understand the whole procedure here. First part is place. It says click on drag to invert the drag. I click on this drag, so drag is inverted here. This is cope and drag method. Then we click on the pattern to put it in the drag. The pattern is put here. Then we use shawl to transfer the sand. This is a transfer step. Use shawl to transfer the sand. Now sand is picked through a shawl. We will transfer it to our drag. After it is filled with the sand, we use rammer to ram the sand. It is rammed, and this ramming is done all generally manual for the sand casting process. There are automated systems to also do ramming, but the strength of the ramming has to be so as it has to be further later dispersed off. Core strength is more than what pattern sand strength is there. Core making I also do as an experiment here. So here it is rammed here. So this is drag. Upper part cope also is to be made, but the sand has a cohesiveness property. If we make cope and drag and do not put any parting material in between, that will stick together. The sand particles will stick together. So we have to put dry sand. It is parting sand that is completely dry, that does not have cohesiveness property, that is put here, that is sprinkled here. So this is my sprinkle step. It is being sprinkled so that the upper part of the flask does not get fixed into it. The sand does not get fixed into it. Now we click on the molding flask so that the upper part is put here. Then it is locked using the pins. Again using shawl, the sand is picked and put here. Now it was filled partially here, and a sprue is to be put in the position. I clicked on the sprue and sprue has come here. Using the shawl, I will now fill it. Now gate is to be put into position. This gate is very generic conical gate. We can design our gate specifically for our own design, the kind of the pattern we have that we have seen in the previous lecture. How do we design the size or the dimensions of the gate? Then using the shawl, I'll completely fill it. Now using rammer, I will ram it so that my system is ready. Now we have to remove the sprue and the riser, that is removed. Now molding flask is now clicked so that it is separated. Why it is being separated now? Because we need to create a runner. There is no connection between sprue and the pattern. The sprue is there, pattern is there. There has to be connection between sprue and the pattern. So that we will use here only human finger only to make this runner. There are tools such as single handheld shawl to make this kind of the runner as well. Now we'll again click on the molding flask and put the molding flask over it and again lock it. Now the part is filling. Separately you saw in the block diagram that furnace had the molten metal ready. The molten metal is there, that is brought using this ladle. Using the ladle we are pouring the molten metal. Now this pour part is there. Next is the cooling part that has to happen. The cooling will happen. After cooling we have to remove the casting. This is the casting that is ready. So this was the virtual simulation. Post test, post casting, let us take some certain questions. Property of sand due to which the gas and steam escapes from the sand is, what is the property due to which it escapes? It is the porosity there. That means permeability is the property of the sand due to which the gas steam escapes through the sand itself. Which of the following is not true about riser? It permits molten metal to rise above the highest point in the casting, this is true. Filling up the mold cavity can be visually checked from it, yes. The casting solidifies directionally towards the riser, yes. Riser and runner extension are used for the same purpose, no. So this D is the correct answer, this is not true of the riser. Next question is, which of the following is not a casting defect? Hot cracks, swell, shrinkage, hot tears. Hot cracks are not a casting defect. The amount of draft required does not depend upon, it depends upon shape and size, it depends upon the molding method, material of pattern irrespectively there to the amount of draft. So material of pattern does not have any linkage with the draft. So this is the right answer. Method of production, yes, it depends on method of production as well, whether automated or manual. Which of the following is not a type of core according to their position? Horizontal, vertical, inclined core is not there. So let me submit, answer is 5 out of 5. This is post test and there are certain references. Generally Campbell is a very common or famous book who designed the manufacturing processes, very basic manufacturing processes. He had given a lot of information specifically about the casting. This is a highly referred book. So this is the virtual laboratory experiment on studying various stages of casting through demonstration of sand casting process. One experiment is taken. Let me now come to the previous tab. I have taken experiment number 1. Next experiment is to study core and core making. Pattern making is one thing. Core making requires higher strength, for which the kingpin is use of carbon dioxide gas, so that the curing of core happens and it does not disperse. Just suppose if some vibration or some small mishandling happens, the core should stay solid. So core making is a process that is also important. The aim is to study making of cores using core sand. In the theory part, it has given the core and core making. Cores are sand blocks that are used to make hollow position in the casting. This we have discussed. The materials which are used in this experiment are water soluble binders, 2 to 4% by weight, oil binders 1 to 3% by weight, pitch and resin binders. These kind of binders could be used. Then binder, clay acts as a binder which makes kaolinite, Paul clay, fire clay, limonite, fuller's earth and bentonite. This all you can read about binders. We have already discussed about this in the theory lectures. Pre-test questions. Pre-test questions before getting into the design are: number one, thermosetting resin is used in core making process because thermosetting resin is used, it imparts high strength, yes, it imparts collapsibility to cores, and yes, it emits a minimum amount of mold and core gases. Yes, that means all of the above are the correct answers. Which of the following properties can be achieved using core binders? Using core binders, which of properties to be achieved? Cohesion. Cohesion is the most important, because the core has to have a strength much higher than the mold. To locate and support the core within the mold, a region is added pattern, core or mold called as, so this is called as core prints. Wire of which material is used for reinforcement of weak cores? Which wire is generally used? It is steel wire. Which of the following is the oldest binder used in making cores? The oldest binder is vegetable oil only. Let me submit 5 out of 5. Pre-test is taken. Procedure is given here. Certain steps. Click on ladle to pour the binder. Click on the core sand to transfer it into the core box. Click on the rammer to ram the core sand into the core box. Click on pin to make a hole into the core. Click on cylinder to pump the carbon dioxide into the core. Click on rammer to ram the core box to loosen the core. That is, core is prepared finally here. Let me come to the simulation and I will go through all these steps: pour, transfer, ram, hole, pump and again ram to get my core finally prepared. Simulation. It says click on ladle for adding the binder. There is a molding sand here. I need to click on ladle to add the binder here. The binder materials, as it was discussed, the binder materials could be water soluble binders, oil binders or pitch on resin binders. So those are added here. So then this is the sand that is ready. This is a core box that will be used to prepare the core. I click on the core box and the sand is now put into the core box, that is we are transferring. This is the second step. Then using the rammer it is set. Using a pin we create a hole. This hole is created why? Because we need to pump in the carbon dioxide. Next is the adding of the carbon dioxide. Why do we need to add the carbon dioxide? It cures it faster, it makes it harder. So carbon dioxide cylinder is here. We click on the cylinder and it will pump in the carbon dioxide. Right? When the carbon dioxide is pumped in, it strengthens or hardens the sand cores, and within seconds, within 20 to 40 seconds, it cures the core completely. Cures means the core is ready to be used. So now I'll click OK, and using a rammer, I'm ramming it from outside, so because this core is to be now removed from the core box. It is rammed from outside. Now you see here the core is removed, right? So this is ready. Just to show you once, okay, if I just zoom it in, all these steps are here. It is also showing what material is being used or what equipment are being used here. I'll reset it and try to show you the step of the core removal once again. This is sand is ready, core box is there in which the sand is transferred. Then using a rammer, we try to get the sand rammed together. Then using a pin, we make a hole for carbon dioxide. Then we use carbon dioxide cylinder to pump in the carbon dioxide so that the core is hardened. Then I say, okay, this is ramming. This is ramming where the core is removed. This core is ready, right? Now, the next step in the simulation, that is post-test questions. The temperature up to which cores are backed by preheating them is, what is the general temperature to which it is heated? It is 650 degrees Fahrenheit. The force which is experienced by the cores while pouring molten metal is, this force is Beyond force. For the casting of aluminium, chaplets used are made up of, chaplets are small materials. For example, it is a I kind of a section, this section T or I section. So, that is used to support the core in the hollow cavity. This core is to be supported. So, those chaplets are used. So, these chaplets are generally made up of the material they are asking, aluminium, copper, steel, zinc are the options. It is generally made up of aluminium. In the casting of aluminium, it is made up of aluminium only. To remove the cores from the finished casting, which of the following processes can be used? Generally, chemical dipping, blowing, washing, all of these are used. In solid silicate carbon dioxide cores, the purpose to pass carbon dioxide gas to the rammed sand is, this you now know very well, to form silica gel which binds sand grains in a strong solid form. This is the answer. Increasing permeability, that is less relevant, increasing collapsibility, increased strength of the core sand. Most relevant is the first part. Let me submit 5 out of 5. This is now ready. Now, these are the references other than Campbell. It has used books by Beeley and Brown, which are there on the foundry technology, and Ferris Foundryman's handbook. So, this was a second experiment that was on core making. These are all very generic experiments, generic or very, I would say, traditional experiments which have been used since ages, since thousands of years. Nowadays, investment casting or automatic investment casting is also there, that is used, where multiple castings or multiple products could be produced in a single pouring. Let me just walk you through that one as well. I come to tab 1, and that investment casting process, that is here. So, this experiment number 8 is to study the various steps of investment casting process. I click on that. So, aim is to study the various steps of investment casting process. Material used is metal die, wax, ceramic slurry, furnace, molten metal. Apparatus used is metal die and furnace. Theory. Big theory text is given here, in which the information on the pattern, mold creation, drying and pouring, time for solidification, casting, removal, finishing, and need or the advantages of the investment casting. So, parts in the investment casting can be automated. This is the one of the major applications. Close tolerance could be given. Then sections as narrow as 0.5 mm have been manufactured using investment casting. Then total weight up to maybe 25 to 30 kgs have been also found suitable for the investment casting technique. Only the disadvantages which have been discussed previously, that it is a little complicated process than the regular single piece casting process. It is relatively expensive. It is not suitable for heavy objects, and it is generally used for the mass production when more number of components are required in a single go. It is generally used for that. Now, let me come to the pre-test questions. Zooming it out. In ideal case, investment casting process can provide tolerances up to 0.08 millimeters. Products produced by investment casting process are generally, it would be small products or the products which are required in large number. Heavy products cannot be produced. Aluminium billets are very heavy. This is not the right answer. Jewelry and surgical instruments, yet this could be the right answer. Rail, it is a big component. Connecting rod and crankshaft, no. So, this answer should be B, or that is jewelry and surgical instruments. Next is automotive part that are made using investment casting process is wall pots, turbine blades, both of them are used or both of them are made. Benefit of using investment casting process is good surface finish, high dimensional accuracy, allows casting of extremely complex parts. All of these are the benefits. Let me come to the simulation part now. Now, the apparatus is being shown here. We have the apparatus, that is the furnace, the metal die, and these are the final castings that we will be having there. It says click on die for inside view of die while wax is being filled. I click on the die, this is the inside view of the die, is the wax is being filled here, right. So, let me see the patterns, how would it look like. The patterns are now here and it is here welded or locked using the hot flame. Click on sprue and pattern assembly to drawn into slurry to make a shell. I click on the sprue and we will put it here in a flask, and this is slurry that is ready. Click on slurry to take out sprue and pattern assembly. If I zoom it in, you can see everything is shown here, things that are used. I click on the slurry and now you can see it is here ready. Now click on sprue and pattern assembly to drawn into the stock to make shell. Click it here, it goes here, and we make a shell here, right. So this shell is there. Now we put it in the furnace and it is heated. Click on the ladle now to pour metal into it. The molten metal is being poured, it is being filled here. We get the final patterns here. We shake the shell to take the patterns out, and these patterns are ready now here. Now we can reset and redo it, restart the simulation to understand everything. You can do it multiple times. Let me come to the next step after the simulation, the post test questions. Liquid which is used for formation of slurry in investment casting is, which liquid was used? Was it water, carbon disulfide, sodium silicate or glycerine? It is sodium silicate. The purpose of dipping and stockowing is performed continuously in the investment casting to achieve, this dipping is done to achieve the required strength. Strength would come through the thickness. So the answer is the desired thickness of the mold is required, that is to be achieved. To remove wax, to cool wax pattern, to remove impurity, no, these are not the answers. To desired thickness, to get the desired thickness is the right answer. Post processes such as grinding, sandblasting, cutting, etc. used in investment casting process. Yes, those are used because post processing to get the final finish, final corners, final sizes are required, which could be sandblasting to descale it, which could be grinding so as the final finish, surface finish is obtained, which could be cutting to remove the unwanted material or any projections which are there. So these are all used. The answer is true. Remnants wax from the mold is removed by which of the following materials? Gas is remnant gas, the gas is which is remained, that is to be removed, that is removed using trichloroethylene. Nitroglycerine, phosphoric acid, water are not the answers. Trichloroethylene is used. I submit the quiz and I get the answers correct, 4 out of 4. References which are used here are by Karunakar and by Singh and Ahuja to develop the simulation process. So these were majorly the casting processes which I have discussed. Now the properties of the pattern, the properties of the sand are also to be tested. There are certain experiments in this direction as well. If you see here, the experiment number 4 to perform strength tests on sands, experiment number 5 to determine the percentage of clay present in the sand, experiment number 6 to determine the mold hardness and core hardness, then to determine the permeability. All these are regarding the properties. Then to find the distribution of sand grains using set of C's. Sand properties are again being discussed here. So these are all properties. Let me take only one experiment out of these. I will pick to determine the mold hardness, experiment number 6 I will pick. So mold hardness test. Here the aim is to determine the mold hardness and core hardness of the given sample. Theory is given here, in which information about the mold hardness and mold hardness tester is there, which is just kind of a dial gauge using plastic sleeve and metallic sleeve. This indicator will let you know the hardness number. Hardness number is there between 0 and 100. To understand more about the hardness testing, you can just watch videos on hardness testing in the course Basics of Mechanical Engineering 1, which was a precursor to this course. So this is hardness. Then for core hardness, a separate dial gauge setup is there, which will also give you range between 0 and 100. So I will just go through the pre-test questions and walk you through the experiment, the simulation. Pre-test question, the question 1 is, which of the following type of instrument types is categorized for mold hardness tester and core hardness tester? So, I have told you those are the dial indicators. So, dial indicators are used. Study about these different kinds of instruments, null deflection, indicating, integrating, recording. You can also visit one of the other courses, engineering metrology by Professor Ram Kumar and I. So, there the different kinds of instruments are discussed. Here indicating instrument is used to understand the mode hardness and core hardness. Mode hardness test is comparable to Vickers hardness test, Rockwell hardness test, Brinell hardness test or Knoop hardness. It is comparable to the Brinell hardness. Molding sand that is naturally moist is, there are different kinds of this sand, green sand, dry sand, parting sand. Molding sand is generally the green sand, which is a mixture of clay and water, so that the mold does not disperse unless the casting has been done completely. So, this is a green sand. The reason for using tungsten carbide is used in scratch type testers. I will show you the scratch type testing. The reason tungsten carbide is used because it is hard. There is an indenter, the pin tip has to be hard. This tip is made out of tungsten carbide. It is hard material, that is why it is used. This is right. Let me come to the procedure. It is showing for mode hardness test, for the core hardness test. There are certain steps here. For instance, for the mode hardness test, we choose the sand for which mode hardness is to be found. We click on shawl, we click on rammer, so that the sand is rammed properly. We click at the center of the molding flask to take reading. We click at the one corner of the molding flask to take reading. We take another corner for, we take readings at multiple points, multiple surfaces of the pattern. Pattern, for example, it is a conical shape, we take at the flank, we take at the tip, we take at the other base, other surface. So, all these surfaces give us the reading. So, the average value of these 5 readings which are taken is calculated to find the final hardness number. Let me come through the simulation, mode hardness. First step is to pick a sand, green sand or baking sand. Now, using the shawl, I will pick sand and transfer it to the molding flask. Say OK. Next step is to ram it down. Preparing the mold to be tested. Next step is to test it. Now, using this, we take the reading at 5 different locations. Here reading is taken at 5 different locations, one is center and 4 corners. The result would be average of this. I click on the result, average of this is my hardness number. This is simply we are taking the readings using the dial gauge. I will just talk you also through the core hardness simulation, core hardness. So, these are 2 cores, green sand core and dry sand core, which are used, and this is the core hardness tester. Let me pick green sand core. This core is there. Just using the hardness tester, it will test on one surface, then it will go to the other surface and test. Then we go to the third surface, it is the base here, test. These 3 surface readings have been obtained. I click on the result to take the average. Hardness number here is 28. So, this is regarding the core hardness. Let me come to the post test questions. Question 1, range of measurement of mode hardness tester and core hardness tester is, this is discussed already, that this range is between 0 to 100. Next is, which tool is used to transfer molding sand into the molding flask? It is simply the shawl is used. How many indentations were made in the mode hardness test? We took 5 readings, 1 at the center and 4 at the corners. What is measured by core hardness tester? Measure the interior hardness of the core. Tip of mode hardness tester is made up of generally the alloy steel. I submit the quiz and I got 5 out of 5. References: use the Sarkaz book to design the hardness testing experiment. With this, I am closing my lectures on casting processes. We will meet in the next week and we will discuss on the forming processes. Thank you.